Boom. Hello and welcome back to Statistics1. Today, contingency tables, joint probability, and fun on the menu. So first of all, what is a contingency table? And what is this all about? Well, we are going to have now multiple variables for probability, not just one. Let's say you are observing Senate, and you have Democrats and Republicans, and you have different age groups, and you are picking one person at random. What is the probability that the one you pick is a Republican in 60s? So we need numbers, data, and we need to present that data, and then we would be able to calculate such a probability. Let's say you want to buy a new car. You have different types of cars, right? Different companies that make cars. So you have German cars, you have Japanese cars, you have American cars, right? Tesla, the best car in the world.
So expensive.
There's a reason for it. So you have all different car manufacturers to pick, and then you have, let's say, different color. Let's say you care about color. So what is the probability that you are picking, blue Tesla or red Toyota or whatever, right? We can come up with those probabilities. Now, remember, every time you're picking at random. What is the probability that in this classroom I'm going to, at random, again, pick, let's say, a male student in 50s? So, again, there is a variable which is male or female, and then there is another variable which would be the age group. In teens, right, 18, 19, maybe 17, we have students, actually high school students, that take courses here. So you can be 16, you can be 15 as well. So in teens, in 20s, in 30s, in 40s. So what is the probability that I'm going to, if I randomly pick a name, let's say you are teaching the online class. You just have a list of names. You don't know who the students are. You've never seen any of the students, right? So what we are going to do is we are going to present those two different variables on the X and the Y in a table, so rows and columns, and then we are going to have totals, because remember, when you're looking for probability, you always have to divide by a total, the total amount of observations, the total with what we call the sample space, which I also call the universe, right, with everything inside. So when you are looking at the contingency table, it is going to have this shape. All right, so this would be the shape for contingency table. These guys over here, how many you have, will be called cells. This one over here is called the grand total. And these two are called marginal total. Marginal total. So this is the way that the table is set. So let's make up the data. So this is going to be a very simple, let's have male, female, and let's have the age groups 10 to 19, so that's teens, 20 to 29, and 30 to 39. So students, let's say, that are in their teens, 20s, or 30s. And we are going to make up numbers now, because I just want to teach the way that we calculate these things. Actually, these are all need to be cells like this. So cells are in this thicker box. And the totals are in the margin. All right, so let's say we have one guy that is in teens and 3 female that are in teens, and then let's say we have 20 to 29, let's say we have 11 guys and 9 female students, and in 30s we have, let's say, 3 and 2, whatever, doesn't really matter. So you can put whatever numbers. Totals, just add across and add down. So when you add, we see we have 4. Oh, these ended up being the same number. I don't want the same number. Let's have the reality of life. More females in the world than male, right? Because there's about 51 female and 49 male in terms of population. So let's have more females in this class. I don't want to have the same number. So we have 14. No, that's 15, right, on the first one. And 16 for the female. And across it's 4, 20, and 7. And either way you add, you will get 31 for the grand total, because you have to. So grand total tells us the amount of students in a classroom. 31 students in a classroom altogether. And this table gives us a lot of data. It tells us there are 15 male students, 16 female students. It tells us that there are 4 students that are in teens, 20 students that are in 20s, and 7 students that are in 30s. This is the data that you can always collect. Just go to any classroom and you can collect this data like that, right? Now, we can do our old probability that we learned earlier by looking and just keep dividing, right? What is the probability that you will at random pick a male student? 15 out of 31, yes. So 15 out of 31 that you will at random pick a male student. What is the probability to pick a female student? 16 over 31. What is the probability that you are going to pick someone in 20s? 20 out of 39. How about to pick someone in... That's what I said, please pay attention. How about someone in 30s? 7 over 31, yes. So all of the basic probabilities that we learned before are simply you are dividing a number that has that characteristic with the total of 31 people present. So this is all of this. Maybe I should put this. Let me just do this. And I say old stuff. How about that? Old stuff, right? Now let's talk about new. Conditional probability. Conditional probability is going to be asking you to pick a male student given that the student is in 20s. Or pick a student that is in 30s given that it's a female. You see, there is that additional part given, and it restricts your pool from which you get to choose. So if I write probability of m given 30, this would be, we will understand this as what is the probability of choosing male student in parenthesis m given, and I'm going to underline that word given, that the student is in his 30s. This is what that notation means with this vertical line between m and 30. Now you can flip them any way you want. Pick a teen given that it's female. Pick a teen given that it's male. Pick a female given that it's 30. Pick a male given that it's 20s, and so on. So you can literally put whatever you want there, but you only have the two variables. One variable is age, and one variable is male or female. So now, what is the way to compute this? Let's think about it a little bit. I am looking at the table, and I'm looking at my problem probability of m given 30. Do we all hear the word given? See, when I say given, that is your pool to pick from. Does that make sense? Can you pick an elephant given deck of cards? No. Can you pick a dairy product given a pile of wood? No, right? Can you pick a branch given pile of wood? The answer is yes, because branch would belong to pile of wood, right? So the other things belong to the wood. But see, the word given is your new restriction and becomes your new sample space. So, male given 30s, your new denominator is going to be 7, because you are given 30s, and there are 7 people in 30s, total of 7 people in 30s. So whatever is in the given spot becomes your new denominator, your new sample space. So I can ask you for a male, right? What is the probability of picking a male out of 30s? You know what I just did? I just erased all of these 24 people when I said given 30s, because I'm only focusing on a group of people that is in their 30s, therefore these 3 and this 4, and that's it. Now probability of choosing, right, become better than picking a male in 30s, and yes?
So if that was reversed, you'd use 15?
Yes, if this was reversed, your denominator would be 15, and you would be picking 3 out of 15. So we'll do that next. So the goal of this exercise is to understand that any time, and if you want to write this down, that'll be great. The given part, right, the second part, that total becomes your new denominator. So the total for the given part, the second part, becomes your new denominator. And that's what's new in what we're learning today. So what is the probability of male given 30? Probability of male given 30 is going to be probability to be a male in this row over here. Probability to be a male is 3. And we have 7 people that are in their 30s. So probability is 3 over 7. Then you can go and get your decimals. Yes?
Is it safe to say that first variable in this conditional probability, which is males, that becomes the new sample population, and the second one, which is in the age of 30, would be the new sample size.
Sample size, well, we call it sample space. The denominator is the sample space. It's all of the, yes. So denominator would be the sample space, and that's what we get. So any one of these, right? Any one of these, right? Any one of these could be your denominator. It's just you have to be careful which one are we looking for. So let's see some examples for this one. So let's go. I'll write these on the board first, and then I'll write it in the notes here. So let's go. Probability P of female given 20s. Probability P of teens given female. Probability P of 30s given male. Probability P of male given 20s. So here are the four, and you have the data. So first one is probability of female given 20s, then probability of teens given females, then probability of that the randomly chosen person is in 30s given male only, and then probability male given 20s. So try all of these, and then I'll write them out.
If your
predominant view approximately. Just need more than 31 questions for second scale. So, anytime you have a text that's very quick, there's an item in the question. So the first again is the key. This demo correct. So the idea is between the two answers that one sounds correct, the other one is correct, but either items. So it was able, even though I know, you still think you need to answer one way to get the and to the says that the
But this one when I was at the 5:30, it was great.
And then he was laughing out loud. There was my first experience. So just 3 years later, I'm taking the 3.
And you can actually watch it.
But then you do that how you want to watch the video.
It just moves constantly. It actually goes pretty fast.
Okay, let's take a look at these 4. And the first one is probability of a female given 20s. Now, when I'm talking about a female given 20s, the rest of the chart disappears because the row of 20s is the only universe I have. So, the rest of the chart disappears because given 20s is what I have in my given spot, right? And that becomes my sample space. So it's over 20, and now I'm looking for a female. There will be 9, so 9 over 20. That's the first. The second question we have is, okay, so now I'm going to erase this. The second question is that the randomly chosen person is in their teens, given females. Okay, if I'm given females, right, then we are going to eliminate the rest of the chart. Because given females means just that column in this case. So given females, there are, the total for females is 16. So my denominator is 16. And I need teens, that's number 3 on top. So 3 over 16. The next question is, person should be in 30s given male. Okay, so given male, that means the rest of the chart is gone. Given male, there will be 15 in the denominator, so that's my sample space. And I need the 30s, so that will be 3 over 15. This one we can reduce to 1/5. And finally, I have a conditional probability for male given 20s. If I'm given 20s, the rest of the chart disappears. So I have male given 20s, that would be 11 over 20. We all have this? So now we're going to do a bigger chart, example for the bigger chart from homework. Now let me just write these here. So I have probability female in 20s is, what is that, 9 over 20?
Yeah.
Probability 10 female. 3 over 16. What's the next one? Probability
30 is male, 3 over 15 or 1/5.
or 1/5. Good.
Probability male of 20, 11 out of 20.
11 out of 20. Thank you. All right, let's take a look at an example from homework. Now, homework has these charts that are not completed, and to be honest, I guess I gravitate towards those on exams because you need to display your knowledge to complete the chart, and then you just read the probabilities off of the chart. Now, what it means, incomplete chart, is some of the numbers are missing, and then you will obtain those numbers either by addition or subtraction. It's not missing information, you have to make something up. There are exactly the numbers that you have to put in. It's just that are not there immediately given. So let's see. Pay grade, those numbers are insane. Farms, U.S. Department of Agriculture publishes information about U.S. farms, Census of Agriculture. There we go. So a joint frequency distribution for number of farms by acreage and tenure of operator is provided. So now we have this big, this is 4.114, and we have this big chart that has lots of numbers and lots of numbers missing. Is it better to show the chart and you draw the chart, or watch me draw the chart and yeah, go from there, huh? Is it better?
Yeah, I'll watch.
This is biggest, as you can see over here. I can make it this big, I can make it this big, and that's it.
Did you do control plus or on
Control plus is only going to work on
the outside?
well, actually no, it works now here too.
I mean, this is using the my math lab, not the other one that we use.
Oh yes, you're right, this is my MATLAB, so it will work here. Okay, I got it, yep. All right, well, this is the biggest we can go. Perfect. The goat?
Greatest of all time.
It's now it's lost in translation. Like I am perfectly
Like G,
aware of what the goat is, but
greatest of all time.
goat, great. Oh, okay, now I see. All right, fine.
To like praise Michael Jordan. Like,
Okay.
You know, A-Rod and stuff. Like really high.
So you just so technically I should say Michael Jordan is goat.
He's a goat.
Okay, I
Mom's a
understand.
goat too, you know. We're not
Or
voting
Okay.
against
talking
each
about
other.
a car. There's also an American-made car that's a goat, and they call it goat.
It's whatever you like. It's a goat. You know, it's a meaningless word.
Oh, it's subject. Okay, I got it. All right, I got it now. So contingency tables are goat because
Is that 50 under 100 or 50 under
180 and then 500. Yes. Do what?
Could you like use a marker and like everything on the board?
Sure, there's a marker for you.
Okay. Give me a second. I gotta do it now.
I would never deny that opportunity for you. Like, why would I? I don't even have to get up now. So this is less than 50. That's A1. A2 is between 50 and 180. A3 is 180 to 500. A4 is 500 to 1000. And A5 is bigger than 1000. And then we have the total on the bottom. So now we make this one stand out. Those are the cells.
Yeah, man.
Yeah, except you don't have to add and subtract to do, correct? All right, so the numbers that are given are 492, 198, 51, 41, 70, 130, skip a cell, 84, 114. Oh, the totals, 15, 21, 541, 17, 14, 44, 38, 660, 368, 149, 172. What happened? Are you filling this up or?
Okay.
I just don't like what I got for the last total on the first column.
$700. You said 739. Yeah. Do we all have 739 there?
Yeah, 749.
739. I'm going to fill these numbers in red. 739 was the number. Now, how'd you come up with 739?
Yes.
You guessed.
I added everything in that column, and then I subtracted by total to get that.
Great. So we add all of these puppies here and subtract from the total of 1521. Excellent. Now that's the same way we're going to get this number, right? In the middle, in the middle column. So what's that number? You add all the cells, so 200, 398. And we subtract that from 541. So
143.
how much?
143.
143.
You want to show your screen so we do it along with you?
No. No, that's why. Better ask for, what is that? Better ask for forgiveness than permission. How does that, is that how it goes?
Yeah.
Great. What is the next thing that I can get? Can I get this number here?
Yes.
Yeah.
How do I get that number?
Add 198 plus 143.
Yes. So we add 198 and 143, so that's 341, and take that away from 368, right? So get 72, no, 27, I mean,
It's 26.
27, good. All right, what else?
And we can get the
What's the number on the total on top? 853. So what's the grand total when you go all the way down now? How much? 2202? 2202. Good. And only one number left. 140. Thank you. Perfect. So this is something that you chase around by simply adding and subtracting. The first question on this homework assignment is to fill in the 6 missing entries. Well, that's the red stuff we just did. Second question is to answer how many cells does this table have? How many cells? 15. That's why we have this black thick border. Cells are only inside. These are cells. The sides are totals. So the cells are inside. I think I had that, right? That was the first thing. Yes. You see the cells are inside and then marginal totals and totals on the outside. Okay, we have that. Good. So we did first question, fill it in. Second question, 15 cells. How many farms have under 50 acres? Now I have to write this question. So how many farms have under 50 acres? Is this a probability question? No. So how many farms are under 50 acres? Did you just say 6? $853. The contingency tables, this table contains the number of farms. This particular data is on 2,202 different farms that are filled in these categories. So we have the operator, full-time, part-time, and whatever else, and then we have the size of each of the farms. So how many farms are we considering? 2,202. How many farms have under 50 acres? This is the row for under 50 acres. The total amount of farms that are less than 50 acres is 853. Next question. How many farms are tenant operated? That would be T3. So how many, so this is full-time, part-time, tenant operated, TO. So how many farms are tenant operated? 140, very good. How many farms are tenant operated? The answer is 140, very good. How many farms are operated by part-time owners, part owners, and have between 500 and 1,000 acres? 130. Excellent. I will read one more time. How many farms are operated by part-time owners and have between 500 and 1,000 acres? Yes, 84. The other one is 50 and yeah, it says 500 and 1,000. So it's 84. Now, so this is question C, question D, question E. So that would be how many farms are T2 and A4. T2 and A4 at the same time, and the answer is 84. So you had the right answer, then you crossed it out and put the wrong answer, and then you crossed it out. Oh no?
I didn't write it yet.
So you just knew what it was.
Yeah.
How many farms are non-full owner operated? How many farms are non-full owner operated? So you have the this should be 4 point tall.
681.
681, correct. That's this one. Because these are the farms, 1,521 are the full owner operated, the part owner operated, and the tenure operated are the other ones. So, question F is asking for T2 and T3. So they're actually looking for not T1, which is T2 and T3, and the answer is 681. Good. And the next one is the last one. How many tenant operating farms have 180 acres or more? Tenant operating farms with 180 acres or more. Tenant operated is in the third column, and we only have 140 available. Tenant operator, so 58. Those would be these three numbers right here. These are the tenant operated farms. That's their column. And these are the ones that have 180 acres or more. So when you add these numbers, you have 58. Let's finish this lecture before I die. And if I die, since there is no canvas, all of you have A because they don't have the grades for you. But it's a win-win actually at this point in time. How many tall farms larger than 180 acres? 4, yeah. Contingency tables. And joint probability. You said 58, right? There we go. Did they ask for any probabilities in this chart? No. No probabilities asked. Let's make up a probability. What's the probability? So, more questions now. Let's go with 2. What's the probability of A3 given T2? And what's the probability of let's do 3 actually. What's the probability of T3 given A5? And the last one is what's the probability of A4?
Very fit, you know what I'm saying?
I don't know if I'm really
Yeah.
nice.
Okay, what do you have? I'm just going to copy your answers and we are done. So we have, so T2 has 451, 541, and we need A3. A3 would be 143, right? Good. A5 has 172. You always start there. And then you need T3, 17. Thank you. When you have a single probability, your grand total is your denominator. So that was 2202, the most number of arms. Total of A4s is 149. Excellent. See you all next week. Bye.